Question 5 is quite a nice question about projectiles. Whenever we consider projectiles, don't forget that you have to always resolve the horizontal and vertical components separately. You can't deal with them at the same time. So let's first identify what we get given in the question. We are told that an experiment is carried out with a clay block placed at the edge of a table that is fired away from the table. The initial speed of the clay block is 4.3 meters per second horizontally. So that's our u in the x direction. The table surface is 0.85 meters above the ground, so that's a distance, or s, and that's vertical height drop, so that's sy. It says, ignoring air resistance, calculate the horizontal distance travelled by the clay block before it strikes the ground. Now, the first thing to do in this case is to work out how much time the block is in the air for. So let's work out, we first need to resolve vertically. So let's write out our five SUVAT expressions, and then let's work out what we already know. So we know that the distance is going to be 0.85 meters. By leaving it as positive, I'm implying that the downwards direction is positive. We know the initial displacement, the initial velocity actually is 0 in the vertical direction. We know that because it says that it's 4.3 meters per second, but only horizontally. We don't know v and y, that's an unknown, but we do know that it's accelerating due to gravity. Again, because we've taken the downwards direction as positive, that's 9.81 meters per second squared. T is what we're looking to find at this initial stage. So what we can then do is find an equation that links S, U, A and T, and that is S equals UT plus a half AT squared. Alright, we then rearrange that for T. First we can get rid of the UT because U, as we've seen here, is equal to 0. When we rearrange that for T, that should come out with T equals 2S over A, all square rooted. We've got all the numbers that we need for that, so you should get an answer for T as 0.42 seconds. The next thing to note is that we are ignoring air resistance. So it says calculate the horizontal distance travelled ignoring air resistance. That means that the horizontal velocity is not going to change across the course of the journey. This means that we can then use the time in the nice simple equation distance in x is equal to the velocity in x, which isn't changing, times by time. That should come out with an answer of, once you plug that into your calculator, you should get 1.8 meters. Then part B then asks us to draw on the path of the block, assuming that air resistance is in place. That means that the horizontal velocity will change over time, so it's not going to reach as far. That's important. The other key point is to make sure that the velocity initially is only in the horizontal direction. So it should look something a little, like this.